Cargo calculations on board tankers is simple as ABC, but sometimes officers are taking this for granted, resulting in difficulties when asked by some third-party inspections or even by their colleagues. It is sometimes difficult to get a hang of these calculations because of different tables, and we got confused on which one to be used and why. In this video, we would aim to simplify the cargo calculations using these tables for you to understand more about this topic. So the first thing we need to understand is the basics of volumes and weight. Volume changes with temperature, but the weight remains the same. When the temperature increases, the volume increases and the density decreases. On the other hand, with decrease in temperature, the volume decreases and the density increases. Volume is usually measured in cubic meter or sometimes in barrels, while weight is measured mostly in metric tons or sometimes in long tons. Densities are measured as density in ton over cubic meter and API or specific gravity, and this density is either in air or in vacuum. Even though in some ships it's more common to measure the cargo weights in air, sometimes you may find the charterers would give the requirements for measuring the weight in vacuum. The difference between densities in air and vacuum is that density in air is used in weighing a product, with the fact that any liquid displaces surrounding air like some kind of buoyancy and therefore a reduction in weight value. It is the most common way on how we weigh a product. On the other hand, density in vacuum is commonly used in laboratories, and the weight in vacuum represents the actual mass of a product without the presence of surrounding air or pressure. There's a simple correlation when using density in vacuum and density in air. Density in air at 50 degrees Celsius is equal to density in vacuum at 15 degrees Celsius minus by the value 0.0011. This value is a constant when using this calculation. Okay, now let's go back to the basics of cargo calculations. We first measure the allage of the tanks by UTI tape or radar gauge in CCR. We also measure at 3 levels and take the mean of these 3 temperatures to get the temperature of the cargo. Now we will get the volumes for each of the tanks using the allage table, and this will be the volume at the observed temperature. Let's take a look at this example. We have 3.6 meter allage in 1/4 cargo tank at the observed temperature 57 degrees Celsius, and this corresponds to volume which is 2717.919 cubic meter. This value is not the measure of how much quantity we have loaded or discharged, so we need to convert the volumes to weight of the cargo using the density given by the cargo surveyor. Cargo surveyors sometimes provide density in vacuum at 15 degrees Celsius and ASTM table to be used. This is commonly in calculating petroleum products and crude oils. Sometimes they provide a table of densities at different temperatures, or density at a particular temperature and correction factor, and sometimes API gravity at 60 degrees Fahrenheit and ASTM table to be used. These procedures are most common on board chemical tankers. On this video, we will focus in using the density at 15 degrees Celsius and ASTM table 54B. This table gives the volume correction factors, or VCF, to find the volumes at temperature for which the density is given. Let's say we have loaded fuel oil and cargo surveyor provided 15 degrees Celsius as 0.992, and we will use table 54B. So first we need to find the VCF. We go to table 54B and look under density at 15 degrees Celsius of 992 and temperature 57 degrees Celsius. So as we can see, for the temperature 57 degrees Celsius, the volume correction factor or VCF is 0.9712. Similarly, we need to find the BCF for cargo temperatures of other tanks. And when the BCF is applied to the volumes at observed temperature, we get the volumes up to 15 degrees Celsius, which is also called the standard volume or net volume. Then we convert the standard volume to weight in metric tons. Getting the weight from standard volume is simple. We have the volume at 15 degrees Celsius and we have the density at 15 degrees Celsius. If we multiply these two, we get the weight by a simple formula. Weight is equal to standard volume multiplied by the density. But remember, the density at 15 degrees Celsius is the density in vacuum. So if we multiply this density with the standard volume, we would get the weight in vacuum. So if we need to get the weight in air, we should use the density in air. What we do is to convert the density in vacuum to density in air by using this formula, and we call this as the weight correction factor. So in our case, the conversion would be density in air is equal to density in vacuum minus 0.0011. So 0.992 minus 0.0011 is equal to 0.9909. When we apply this weight correction factor to the standard volume, we get the weight of the cargo in air. Repeat these steps to other cargo tanks and you would get the total quantity of cargo loaded. Take a look at this example of Alid's report on my vessel. In one port cargo tank, we measured 3.63 meter ullage and a temperature of 57 degrees Celsius. Using the ullage table, we would get the observed volume as 2717.919 cubic meter. Then, we take a look in table 54B and we would get 0.9712 as the BCF. We will have our standard volume by multiplying the observed volume to the BCF. And to have our weight in metric tons in air, we should multiply the standard volume to the density in air or weight correction factor. And we will have the weight as 2615.622 metric tons in air. I hope you now understand the basics of cargo calculation. For you to be more familiarized, I suggest you make your own calculations on your vessel more frequently, and you will find that this is not as difficult as it seems.